All right, everybody. Let's start 10.3. If you made it here, this means you made it past the first exam. Breathe, it's over with, right? Now we keep chugging on the calculus. And now we get to keep using the power rule, the shorthand derivative, from now on, and adding more rules to it. So today's lesson is about products and quotients, so how to use the product rule and quotient rule for derivatives. They make a complicated derivative, or they make the derivative of a complicated function easier. Or maybe they just make it more complicated. Who knows, right? But once again, after you apply the calculus, the rest is algebra. So let's go over the product rule. So if f and g are both differentiable functions, then the derivative of f of x times g of x is given by f prime of x times g of x plus g prime of x times f of x, or just remember this formula, f prime g plus g prime f. If you know that formula, that is the formula for product rule. If we follow that, we should be fail-safe in the calculus part. In the algebra part, not so safe. Okay, so let's go ahead and try out the product rule. Zoom in. All right. So when you start the product rule, you want to label what function is f and what function is g. So here, 2x squared is going to be my f. 3x to the fourth minus 2 is going to be my g. All right. Now, let's write them out. So here is f. F is 2x squared. G is 3x to the fourth minus 2. Now, in order to fulfill the formula, we need to take the derivative of f and the derivative of g. So the derivative of f, the derivative of 2x squared, 4x. The derivative of g, 12x cubed. And now remember that we are taking the derivative of f of x, so we rewrite that here. And all we have to do now is follow the formula for the product rule. F prime g, which is 4x times 3x to the fourth minus 2, plus g prime f. 12x cubed times 2x squared. Now, from here, the calculus is done. The rest is purely algebraic. Distribute, simplify, combine. So, f prime x, distribute that 4x, 12x to the fifth minus 8x plus 24x to the fifth. Combine like terms, and it's done. 36x to the fifth minus 8x. And that's it. That's using product rule. All right. So again, we use product rule to make a complicated function's derivative a lot easier. But what if we had distributed this function from the beginning? You would get 6x to the 6 minus 4x squared. Well, what is the derivative of 6x to the 6? That is 36x to the 5th minus the derivative of 4x squared, 8x. And oh my goodness, we would have been done a long time ago. But once again, the idea is to show product rule because sometimes the functions will not be that easy. But again, there is another way that's showing you another method on how to find the derivative. Okay. Let's try product rule again. All right, to start this one, once again, label F and label G. Here's F, there's G. Bring them out. F equals 3x cubed. G equals 2x squared minus 3x plus 1. Take the derivative of F, take the derivative of G. F prime is 9x squared. G prime is 4x minus 3. Okay, and then just follow your product rule. We're taking the derivative of y, so I'll write y prime equal to, and then follow your product rule. F prime G, 9x squared times 2x squared minus 3x plus 1 plus G prime F. Four x minus 3 times 3x cubed. Once again, calculus is done. The rest is purely algebra. Distribute, distribute, simplify. (18x to the 4th minus 27x cubed plus 9x squared plus 12x to the 4th minus 9x cubed. Combine like terms, 18 and 12, what's that? 30x to the 4th, 27x cubed, negative 9x cubed, negative 36x cubed. Let's see, so I did my 4s, so that's done. Oops. Gone, 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 gone. Left with 9x squared. All right. And there it is. All right, that's product rule. Let's keep going. (3x plus 2 is my F. 4x minus 5 is my G. Label F and G. So here, F is 3x plus 2. G is 4x minus 5. Take the derivative of F. Take the derivative of G. F prime is 3. G prime is 4. We are taking the derivative of G of X. So the next step is to have g prime x equal to, and once again, follow your product rule. 3 times 4x minus 5 plus 4 times 3x plus 2. Calculus is done. Rest is algebra. Distribute the 3, distribute the 4, simplify. 12x minus 15 plus 12x plus 8. 24x minus 7. Done. Yeah, guess I could have used more room. All right, so C, and then to D. Once again, product rule. Label everything. F, G. F is x squared plus 2. G is x squared minus 3. Derivative, F prime, 2x. G prime, 2x. We are taking the derivative of h of x. So, next step, h prime x, and follow your product rule. 2x times x squared minus 3 plus 2x times x squared plus 2. Calculus is done. Algebra on. 2x cubed minus 6x plus 2x cubed plus 4x. Combine like terms. 4x cubed minus 2x. Done. All right. D, and then E. More product rule. All right, still going. Let's do this. Not too bad, right? Okay. So label x squared as f and e to the x as g. So f equals x squared, g equals e to the x. F prime is 2x. G prime, still e to the x. Taking the derivative of f prime of x, so start with that. F prime of x, and follow your product rule. F prime g, 2x e to the x, and g prime f, e to the x times I'll put in parentheses, x squared. And honestly, there's nothing else you can do here. You can't even combine like terms. So we can just rewrite this as 2x e to the x plus x squared e to the x. I mean, there is one more thing you can do. If it does ask you to super simplify, then you just have to notice the common factors. And the common factors are x and e to the x. So this could be an answer if you were told to factor. I can take an x e to the x out, which would leave me with, what is it? 2 plus x. If it tells you you need to keep going. Okay. 4, another product rule. There's f, there's g. F is x to the 4th. G is the natural log of x. F prime, 4x cubed. G prime, 1 over x. Taking the derivative of f of x, so f prime x, and follow your product rule. All day, all day. 4x cubed times the natural log of x plus one over x times x to the 4th. All right, clean up. Four x cubed natural log x stays 4x cubed natural log x. And 1 over x times x to the 4th becomes x cubed. This is the same as saying x to the 4th over x, which gives me x cubed. Okay, that's done. But once again, if it did tell you to super simplify, this does have a common factor of x cubed and would leave you with 4 natural log x plus 1. All you do is factor out the x cubed. Okay, perfect. I think that does it for product rule. Now on to quotient rule. So quotient rule is for quotients, for fractions, right? All right. So the formula for quotient rule is the derivative of f of x over g of x is going to be f prime of x times g of x minus g prime of x times f of x all over g of x squared. Or keep it simple with what I wrote here. Just know this formula, f prime g minus g prime f all over g squared. A lot easier to memorize. Okay, so once again, we have to label what f and g are and follow the formula. If we follow the formula, we're gonna be just fine. All right. So here we're using quotient rule. So the numerator will be f, and the denominator will be g. F is x squared. G is 2x minus 1. Take the derivative of f, giving me 2x. Take the derivative of g, giving me just 2. Okay. We are we are doing the derivative of f of x. So you get f prime of x, and now we follow the formula for the quotient rule. It's still f prime g. So 2x times 2x minus 1, but now it's minus g prime f 2 times x squared all over the original denominator of g, which is 2x minus 1, and you square it. That's it. So that's all we're following is that formula above. F prime g minus g prime f over the original denominator g squared. Now, calculus is done. Rest is algebra. Equal to, go ahead and distribute, 4x squared minus 2x minus 2x squared over the same denominator. And then combine like terms, and you get 2x squared minus 2x over 2x minus 1 squared. Now, I would say this is done, but it is too easy to see that there is a common factor of 2x in the numerator. So you can take that out, and you would get 2x times x minus 1 over 2x minus 1 squared. And now it's done. Nowhere else we can go with that. Okay. Okay, quotient rule. Almost the same, right? Label F, label G, follow a formula. Do it again. Numerator is F, denominator is G. F is t squared minus t. G is t cubed plus 1. Take the derivative of f, 2t minus 1. Take the derivative of g, 3t squared. We are taking the derivative of y. So we'll start with y prime and follow your formula. F prime g very important to put parentheses on these. And g prime f. So minus, because that's part of the quotient rule, minus, and I'll just put parentheses on everything. 3t squared and t squared minus t over the original denominator of t cubed plus 1 squared. And I realize that here should be a plus 1. There we go. 2t minus 1, t cubed plus 1, minus 3t squared, t squared minus t. Okay. Ugh. There it is. Quotient rule's done. Calculus is done. Algebra time. You're going to have to FOIL the first two. So FOIL these two. Two t to the fourth plus 2t minus t cubed minus 1 minus 3t to the fourth plus 3t cubed. Negative 3t to the fourth plus 3t cubed all over t cubed plus 1 squared. Okay, combine like terms. I've got 2t to the fourth, negative 3t to the fourth. I've got negative t to the fourth. Negative t cubed, positive 3t cubed, that is 2t cubed. And then all that's left is that 2t minus 1 over t cubed plus 1 squared. And there is nothing else that we can do there. So we are done there. Nothing else that we can do. All right. Perfect. More quotient rule. That one had too many t's in it. I need to change that to x's or something. Okay, C. Quotient rule again. There's F, there's G. Bring it out. F is x squared minus 3. G is x squared. F prime is 2x. G prime is also 2x. All right, so this isn't an equation like the last ones. So this says take the derivative of this rational expression. So we start by rewriting it as d over dx of x squared minus 3 over x squared equal to, and now we follow the product rule, the quotient rule. So f prime g, 2x times x squared minus g prime f, 2x times x squared minus 3 all over the original denominator of x squared squared. So f prime g, g prime f, all over g squared. All right, calculus is done. Clean it up. 2x cubed minus 2x cubed plus 6x. Yep, 2x cubed minus 2x cubed plus 6x all over, and x squared squared means x to the fourth. And then your 2x cubes will cancel. Gone, gone. And we get 6x over x to the fourth, which reduces to 6 over x cubed. All right. All right, next one. All right, label f and g again. So numerator, denominator. Color where we on? There's green, purple. There's f, there's g. F is x squared plus 1. G is 2x minus 3. F prime is 2x. G prime is just 2. Taking the derivative of f of x. So down below, f prime x, and follow quotient rule. F prime g, 2x times 2x minus 3 minus g prime f, 2 times x squared plus 1 over the original denominator, 2x minus 3 squared. Okay, and like I said a million times before, right? Calculus is done. The rest is strictly algebra. Okay. So f prime of x, 4x squared minus 6x minus 2x squared minus 2, all over the same denominator. Clean up. F prime x gives me 2x squared minus 6x minus 2 over the same denominator. Now, this could be done, but we also notice that in the numerator, there is a greatest common factor of 2. So if I take that out, I get x squared minus 3x minus 1. 2x squared, 6x minus 2 over 2x minus 3 squared. And that's it. We can't do anything else with it. X squared minus 3x minus 1 is not factorable because there are no factors of 1 that can make 3. Okay. I think we're on our last 2 examples, right? That's it? Yep. Save the best for last, right? These e to the x's. Here's f. There's g. F is 1 minus e to the x. G is 1 plus e to the x. F prime, the derivative of 1 minus e to the x is negative e to the x. G prime, the derivative of 1 plus e to the x is just e to the x. There's our derivatives. Now let's follow the quotient rule, taking the derivative of f of x. So f prime of x and follow your quotient rule. Negative e to the x times 1 plus e to the x minus e to the x times 1 minus e to the x all over the same denominator, 1 plus e to the x squared. Okay. All right, calculus is done. Let's algebra on and distribute. Negative e to the x times 1 is negative e to the x. Negative e to the x times e to the x. Okay. So that's going to use your exponential properties. So when you say e to the x times e to the x, remember if you have the same base, you add your exponents. So this becomes e to the 2x. This has the same properties as x to the m times x to the n gives me x to the m plus n. So same base, add your exponents. So that's all that's going on here. So down here you get negative e to the 2x. And then distribute again on the other one. Negative e to the x plus e to the 2x. All over 1 plus e to the x squared. And your e to the 2x's will cancel. And what we are left with is f prime of x is negative 2e to the x. So I added those two. Negative e to the x minus e to the x is negative 2e to the x over the same denominator of 1 plus e to the x squared. Okay. There it is. Not bad. Last one. Quotient rule again, and here's f, there's g. And f is 2x, g is 1 plus the natural log of x. Derivative of f is 2. Derivative of g is 1 over x. Taking the derivative of f of x, so down below, f prime of x, and follow your quotient rule. 2 times 1 plus the natural log of x minus g prime f. So for that one, I'm going to put in parentheses. No, I can actually make this 1 over x times 2x. There you go. That'll be in parentheses. All over the original denominator of 1 plus the natural log of x squared. Calculus is done. Algebra on, home stretch. 2 plus 2 natural log x minus, and 1 over x times 2x is just 2. Over the same denominator. Your 2's will cancel. And we get left with 2 natural log x over 1 plus natural log x squared. Nothing else we can do there. And that is it for product and quotient rules. Formula is easy to follow. The calculus is easy. The hard part is just getting down with the algebra. Okay. All right, I guess that is it then. Perfect. All right, till next time.